Hey there and welcome. Today, we're going to dive into a process that honestly feels a bit like a magic trick, but I promise you, it is pure science. We're talking about electrolysis, a super powerful technique that literally splits matter apart to build our modern world. It's a process that's happening all around us, usually completely unseen. So let's pull back the curtain and see exactly how it all works.
All right, so let me kick things off with a question for you. Do you think you can take something as common as water, the stuff in your tap, add just a little bit of electricity and turn it into fuel? I mean, it sounds like something straight out of science fiction, doesn't it?
Well, believe it or not, the answer is a huge yes. With a process called electrolysis, you absolutely can. We can split water into its two core components, hydrogen gas, which is a super clean fuel, and oxygen gas. This isn't make-believe. It's just amazing chemistry in action.
So, how in the world does this work? I mean, this incredible splitting power. Let's break it all down.
At its core, electrolysis is actually pretty straightforward. The name itself is a huge clue. You've got electro for electricity and lysis, which is just a fancy Greek word for splitting apart. So we're using a direct electric current to force a chemical compound to do something it wouldn't normally do, break down into its most basic parts.
Okay, so to pull off this little bit of chemical magic, you're going to need a few key ingredients. Let's take a look at what's in our toolkit.
First up, and this one is absolutely crucial, you need something called an electrolyte. Now, this isn't just any liquid. It has to be a substance, like a salt or an acid, that when you dissolve it or melt it, it breaks apart into these little charged particles called ions. And that right there is the key. Without these free-moving ions, the electricity has nowhere to go. They are basically the highway that the current needs to travel on.
So how does that happen? Well, think of water molecules as tiny little magnets. As you can see right here in this diagram, their positive and negative ends literally grab onto the ions in a compound and just pull them apart. This whole process sets the ions free, letting them float around and carry that electric charge.
Okay, so let's put it all together. Our complete electrolysis toolkit looks something like this. We've got our electrolyte, that's the liquid highway for the current. We've got electrodes, which are just metal or graphite rods that act as the on-ramps and off-ramps for the electricity. And finally, you need a DC power source, usually a battery, which is basically the electron pump that gets the whole party started.
All right, we've got our toolkit. Now let's zoom in on where the real action is happening. And it all comes down to the electrodes. It's a tale of two opposing poles, and each one has a very specific and very different job to do. So, say hello to the stars of our show. The anode, which gets hooked up to the positive side of the battery, and the cathode, which is connected to the negative side. Everything that happens next, all the chemistry, happens right at the surface of these two poles.
This table really breaks it down nicely. The positive anode attracts the negative ions, which are called anions. Meanwhile, the negative cathode attracts the positive ions, which are called cations. And at the anode, a process called oxidation happens. At the cathode, reduction happens. See how it works? Opposites attract. It's this perfect balanced system. So what exactly is oxidation? Well, think of it this way. It's all about losing electrons. The negative ions get pulled to that positive anode, and once they're there, they're basically forced to give up their extra electrons. They get oxidized. And then, over on the other side, at the negative cathode, we have reduction. And you guessed it, it's the total opposite. This is all about gaining electrons. The positive ions are drawn over to that negative cathode, and they get to pick up the electrons they've been missing. They become whole, neutral atoms again. They've been reduced. So you've got this give and take happening at the same time, right? The losing of electrons, oxidation, and the gaining of electrons, reduction. Together, we call this a redox reaction. And you can't have one without the other. This whole coordinated dance of electrons, that's the engine that powers the entire process of electrolysis.
Okay, so that's the science behind it. Pretty cool, right? But you might be wondering, why does any of this matter? Well, it turns out this simple process is an absolute giant in the industrial world.
Yeah, this is so much more than just a cool lab experiment. It's like this invisible force humming away in the background, making the stuff that's absolutely essential for our modern lives.
Let's check out two really big applications to see what I mean. First, we've got electroplating, which is basically giving stuff a shiny new metal coat. And second, there's electrorefining, which is like a super-powered filter for making metals incredibly pure.
So check this out. This is electroplating in action. Say you have this brass cup, and you want to make it silver.
You make the cup the cathode, the negative pole. Then you take a piece of pure silver and make it the anode, the positive pole. The silver anode slowly dissolves, sending silver ions on a journey across the electrolyte where they deposit in a perfect, thin layer right onto the brass. And that's it. That's how we get beautiful jewelry, those shiny chrome bumpers on cars, and even rust-proof tools.
Electrorefining is just as clever. Here, you start with a big, chunky slab of impure copper and make it the anode. As the electricity flows, only the pure copper atoms dissolve and make the journey across the electrolyte. They plate themselves onto a super thin sheet of pure copper on the other side, the cathode, making it grow bigger and bigger. And all the junk, all the impurities, things like gold and silver, actually, they just fall to the bottom as sludge. This whole process is how we get the 99.99% pure copper that our phones, computers, and basically all modern electronics rely on.
And that really brings us full circle. Just think about it. We've seen how this one process can take plain old water and turn it into clean fuel. It can put a beautiful silver coating on jewelry and purify the very metals that power our entire digital world. It's this fundamental tool for taking matter apart and putting it back together in totally new, incredibly useful ways. And that just leaves you with one big question, right? If we can already do all this, what else can we build with it? What comes next?